Let's apply the connections of position, velocity, acceleration, and distance with another problem. So we have a train approaching a station. So it begins at t equals 0, slowing down from 80 miles per hour. Okay, so according to the acceleration function, a of t equals negative 1,280 times 1 plus 8t to the negative 3, where t is greater than or equal to 0 is measured in hours. How far does the train travel between t equals 0 and t equals 0.2? Ooh, okay, that's a good thing. All right, so a couple things. One, we notice it's slowing down from this value. So that's telling us that V0 is 80, right? And it was positive because, of course, it was going right on the tracks. All right, so they want us to find the distance. How far does the train travel? So they're asking us for distance. Distance, of course, would be the integral of from 0 to 0.2 of the absolute value of velocity. Okay, so that means I'm going to have to find velocity, and then I'm going to have to find the absolute value of it. So let me work on that first. So the first step I need in order to be able to solve this problem is I need to be able to find v of t. So step one, let's find v of t. Shall we? Okay, well, velocity is the integral of acceleration. That just is true, right? So I want to take the integral of negative 1,280 times 1 plus 8t to the negative 3 dt. Well, that is a function nested inside another one, so we are going to need u substitution, where u is 1 plus 8t, du is 8 dt, because that's the derivative of that. I don't want the 8. Maybe I do, but I don't want to deal with it. So 1/8 du is equal to dt. All right, therefore I can rewrite this, keeping all of this in mind, as the integral of negative 1,280 times 1/8 times u to the negative 3 du. Okay, so I have no idea if 1,280 is divisible by 8. Let's go down here and find out. Yeah, it's 160. Lovely. I figured it would work out nice, but, you know, it's nice to have my instincts backed up by the computer. All right, so this is negative 160, and then the integral of u to the negative 3 would be u to the negative 2, and then times a half, because we always multiply, times negative a half, excuse me, because you always multiply by 1 over the new power, plus c. Okay, so that would be 80 times 1 plus 8t to the negative 2 plus c. Now that's a general solution. It's not the particular solution yet. We need to find our particular solution. All right, so it's 80 times 1 plus, oh, I know. I wasn't happy with my use of blue. I wanted to make it orange to make it clear. Okay, so now we cannot avoid using the fact that we know V0 is 80. So we're going to solve for C, excuse me, solve for C. You cannot avoid this, and do not, because if you try to, you can get into big trouble. So be sure to do this. It's tempting to just say, oh, well, of course it's 80. It might be, but we'll find out. So we know V0 is 80. So it's tempting to go, oh, then that's 80. No. Don't do that, right? It won't be right, for starters. Okay, so V of 0 is 80 times 1 plus 8 times 0 to the negative 2 plus c. And I happen to know that that is equal to 80. Okay, so this is 80 times, well, that's 1. And 1 to the negative 2 is 1, so this is 80 plus c equals 80. So c was 0. You have to solve for c, right? The only time you can kind of get out of it a little bit is with polynomials, but this is not a polynomial, right? So be sure to do this. This is not a polynomial function. So you have to check and figure out what your c is. So that means that v of t, I should say therefore, that's the logic notation for therefore, by the way. So therefore, v of t is 80 times 1 plus 8t to the negative 2 plus 0. Or in other words, it's 80 over 1 plus 8t squared. This is not an answer. It's just the beginnings of the answer. All right, so I need to graph that because I need to know what that looks like. Because I'm going to need to know if it becomes negative at some point. Because if it is, then I will have to deal with that. But there it is in all its glory. It's always positive. From 0 to 0.2. Woot, that's great. So let me draw a picture of that on my paper. We're super happy about this. So this is the velocity function. So let me graph it, and then I'll bring it back on the page. So we have from 0 to 0.2, and we're going, it starts off at 80, looks like, and goes down. All right, well, I'm always happy about that. I am super happy because we can make a note. V of t is always positive. Woot. Now, why is that woot? Well, because that means that I won't have to separate. The integrals, right? Remember how when you take the integral from a to b of the absolute value of v of t dt, that could mean a to c v of t dt plus, and then c to b of negative v of t dt. Like, I won't have to do any of this. I will not have to do it because it's always positive, so I won't have to bother with all that garbage. And that's why I said, woot, smiley face, not having to do it. I like it. All right, so this means that the distance, total distance traveled, is equal to the integral from 0 to 0.2 of the absolute value of v of t, but that would just be equal to the integral of v of t because it's always positive. Yay! Right? I won't have to bother with the whole separation thing. Yay, team. All right, so this means that I can just say, hey, all right, I want to take the integral from 0 to 0.2 of 80 times 1 plus 8t to the negative 2 dt. I'm going to need u substitution. I can see it from a mile away. I have a function nested inside another function. Okay, so we got to go somewhere and figure this out. U is 1 plus 8t. This is looking familiar. Du is 8 dt. I don't want du, so I want 1/8 du, which is dt. Okay, so then when I rewrite my integral, I'm going to say 80. Oh, I don't need the 80 there. I guess I'll just leave it. It doesn't hurt me. 80 times 1/8. And then u to the negative 2 du. Now here's the problem. If you write the numbers 0 and 0.2, you are wrong. Wrong, 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 wrong. You can't do that. So you cannot put 0 and 0.2 because those are t values. The differential tells you that these are t values. So you need to go find new values. Okay, when t was equal to 0, 1 u of 0 is equal to 1 plus 8 times 0, which is 1. Therefore, my bottom number is now 1. When t was equal to 0.2, u of 0.2 is 1 plus 8 times 0.2, which is 1.6 plus 1, which is 2.6. So this top number is now 2.6. You must switch your limits of integration with u substitution. Must. Right? Okay, so then this is pretty easy, actually. So 80 times 1/8 would just be 10. And then I'm going to integrate this. So the integral of u to the negative 2 is u to the negative 1, and then multiplied by the reciprocal of that. So it's going to be 10 times negative 1, u to the negative 1, from 1 to 2.6. Okay, so that's negative 10 coming out in front. And let me remind you that a negative power is 1 over u. So you're really taking 1 over u from 1 to 2.6, which is negative 10 times 1 over 2.6 minus 1 over 1. And this is what we have Desmos invented for, yes? This is what it's for. And we don't have to do any of this stuff by hand. All right, so, I actually already did it. It's right there. 6.1538. So 6.154. And of course, it's miles because it's distance. And this is a train that was working in miles per hour. So because it was in miles per hour, it has to be miles for our distance.